Today we're going to talk about how to solve a system of equations and inequalities. So first let's talk about a system of equations. You can solve algebraically by substitution or elimination. You could also solve graphically, where you graph both of the lines on the same coordinate plane and find where they intersect or cross. Okay, so let's look at number one. Number one says to solve the system using elimination. Now, in order to use elimination, you want to get one of the variables to eliminate or cancel out. And to do that, you need to make sure that everything's lined up. So all of your x's are in line, all of your y's are in line, your equal signs, and then your numbers. It doesn't have to be necessarily in this order as long as everything is arranged on top of each other. Okay, so then you want to look and see if when you add straight down, do one of your variables cancel out? And in this case, no. 4 plus 5 is 9, negative 3 and negative 2 is negative 5, so nothing cancels out there. That means we're going to have to multiply either one or both equations by something to get opposites. Okay? So I'm going to look at this and I'm going to say, okay, well, I can multiply 4 by 5 to get 20, and I can multiply 5 by 4 to get 20. But 20 and 20 are not opposites. 20 and negative 20 are opposites, so I'm going to make one of those negative. When I do that, I need to multiply the entire equations by those numbers. So, if I multiply everything in this equation by 5, I get 20x minus 15y equals 40. Likewise, I'm going to distribute the negative 4 into the second equation, all three pieces, so I get negative 20x plus 8y equals 44. Okay, so now what we're going to do is we're going to say, do we have opposites? Yes, 20 and negative 20 are exact opposites. When you add those together, you get 0, or they cancel out, or eliminate. Negative 15y plus 8y is negative 7y. 40 plus 44 is 84. You're going to solve this by dividing by negative 7, and you get negative 12. That is y. Now you need to find x. To find x, you're going to take the value of y and plug it in to y in either equation. It does not matter. But I'm going to go ahead and take the top equation, 4x minus 3y equals 8. I know that y is negative 12, so I'm going to say 4x minus 3 times negative 12 equals 8. Solve this equation for x. 4x plus 36, because a negative times a negative is a positive, equals 8. Subtract 36 from both sides. Get negative 28, and when you divide by 4, you get x equals negative 7. You have now solved this system by elimination. You have the value of x and you have the value of y. You can actually write the answer as an ordered pair, x, y. So negative 7, negative 12. Okay, so now let's move on to example number 2. It says solve the system using substitution. That means that you need to have one of the variables by itself, and you're going to substitute whatever it's equal to into the other equation. So, let's first talk about what variable is easiest to solve for. If a variable has a leading coefficient of 1 or a coefficient of 1, then it's going to be a lot easier to solve for than if it doesn't. So if I solved for this y right here, at the end, I would end up having to divide by 7, and I'm going to get some fractions in my answer. It's okay, but it makes it a little bit more challenging to work with. So instead, I'm going to take this equation, and I'm going to solve it for either x or y, and it doesn't matter because they both have a coefficient of 1. So what I'm going to do is I'm going to solve for x. I'm going to subtract y from both sides, so I get x equals 2 minus y. I know that x is equal to 2 minus y, so I can substitute in 2 minus y into the other equation for x. They are the same thing. So when I do that, I take this x out and I put in, or substitute in, the 2 minus y. So 2 times 2 minus y, and notice I put it in parentheses because there's more than one term there, and everything else stays the same, so plus 7y equals 9. Solve for y. So at this point, I should only have one variable. If I have more than one variable still remaining, I've done something wrong. Distribute the 2, and I get 4 minus 2y plus 7y equals 9. Combine like terms here. We get 4 plus 5y equals 9. I want to get y by itself, so I'm going to subtract 4 from both sides. I get 5y equals 5. When I divide, I get y equals 1. We are halfway there. We know what y is, so we have to find x. If I take y and I plug it in to what I started with, I can find x very easily. So x equals 2 minus, we know that y is 1, so we plug in 1, and we get x equals 1. Again, we can write this as an ordered pair, 1, comma, 1. Okay, so what do these ordered pairs mean? Those are the solutions to the system. That means that that point, that value of x and that value of y, work in both equations. So if you were to plug them back in, it would work in both equations. Okay, so now let's look at this solving graphically. The direction said that we have to graph both equations, or both lines on the same coordinate plane, and see where they cross or intersect. So for number 3 here, the first equation is in slope-intercept form. Remember, y equals mx plus b. We start with the y-intercept of 5 on the y-axis. So 1, 2, 3, 4, 5. That is our starting point for that line. Our slope is -4, or -4/1, so the line should be going down. We're going to go down 4 over 1. Down 4 over 1. Connect the dots. Then, for the second equation, we are going to have to put this into slope-intercept form, so we're going to subtract x from both sides. We get -y equals -x minus 10, and then we're going to divide by a -1, and we get x plus 10. If you wanted to, you could graph this in intercept form, but I think most people kind of default to the slope-intercept form. So we will first plot the y-intercept, which is 10, almost off of our graph there, and our slope is 1, so up 1 over 1. But instead of going up and to the right, we can go down and to the left, because our line from left to right is still going up. We check to see where they intersect, and it looks like they intersect at this point right here, which would be -1, 9. That is the solution to that system. Okay, so now let's look at number 4. Number 4 is a little bit different because it is a system of inequalities. Okay? You are still going to graph them on the same coordinate plane, but remember that if it has a greater than sign or a less than sign, it is going to be a dotted line. If it's greater than or equal to, less than or equal to, it's going to be a solid line. And you must shade. And you're looking for the overlapped shading. Any point that lies in the overlapped shading is going to be a solution to the system of inequalities. So let's look at the first equation. Y is greater than -x minus 2. The y-intercept is -2. And the slope is -1. So we're going to go down 1 over 1, down 1 over 1. This is going to be a dotted line because of the greater than sign. There's no less than sign. And we want to shade greater. So where are the y's greater? Okay, so we have two parts of the y-axis. We have this upper part and we have this lower part. Where are the y's greater? on the upper part. So we're going to shade up. And then we must graph the second line. So again, we're going to put this in slope-intercept form. We're going to subtract 3x from both sides. And then we're going to divide by a -1. But remember, when you divide by a negative, your sign flips. And we have less than or equal to 3x plus 1. So the y-intercept is 1. Our slope is 3, so up 3 over 1. This is going to be a solid line because of the or equal to. That means that the points that are actually on the line could be part of the solution. And we need to shade this. Where are the y's less than? So we have this part of the y-axis. We have this part of the y-axis. Where are they less than? Down. So we will shade down. So what you are looking for now is the overlapped shading. You will notice we have blue shading. We have yellow shading that overlaps to form green shading. So any point in the green shaded area, like 4, 0, is a solution. But if you look at -4, 0, that is not a solution because it is not in the overlapped shaded. So even if you looked at 1, 2, 3, 4, 5, 6, let's do 0, 6. That's in the blue shaded area, but not the green where it overlaps, so that also is not a solution. Okay. Number 5, word problem. We're going to apply some of the stuff that we've talked about. Tickets for admission to a high school football game cost $3 for students and $5 for adults. During one game, $2,995 was collected from the sale of 729 tickets. How many students attended the game? Okay, so this is telling us what our unknown is. That's going to be one of the variables. So I'm going to say x is the number of students. We also do not know, they don't specifically ask us for it, but we don't know the number of adults either. So that's going to be my other variable. This is called defining your variables. Okay, so now with those variables, let's write two equations. If you have two unknowns, you're going to write two equations. And what you're going to look for is, we've got some costs here per ticket and a total cost. Okay, so we've got a total cost of $2,995. Well, how did they get that? They collected $3 from every student and $5 from every adult to give them a total of $2,995. They had a total number of sales as well. They had 729 tickets. We don't know how many were students and we don't know how many were adults, but we know that if we add the students and the adults, that's going to give us 729 total tickets. Now, you can solve this system by substitution or elimination. You could graph it as well, but it's pretty large. So your homework or your checkpoint is to solve this system algebraically, either by substitution or elimination, so that you have the number of tickets or number of students who attended the game when you walk into class tomorrow.